Hello everyone. So today we're going to attempt to scrape a Pokemon website. So if you all watched Pokemon as a kid, this tutorial is going to be fantastic. So this tutorial will cover web scraping, databases, and if you are patient, some analytics and even a very pretty GUI, which would be our Pokedex. Before going any further, let's look at the website that we want to scrape. So by the way, this Ipython notebook is in the description section, so feel free to click on the link and please subscribe to my channel. And here's our website. So pokemondb.net/pokedex/all. So this website basically has all the Pokemon information that we care about, and we will try to parse all this information out of the database and store it on a pandas data frame. Before we go any further, let's look at the HTML codes. So right click and inspect elements. As you can see here, the database is actually stored in tbody as a table. TR is our row and TD is each of the data point or the column in a particular row. So what we care about is going through each of this row and actually storing them on a nice pandas data frame. So before moving any further, let's take a look at our Python codes. First off, let's import some libraries. So for scraping our website, we're going to need requests, which basically allows us to get all the HTML information, and then lxml.html, which will allow us to convert all that information into something that's readable by Python. Matplotlib will be used for any analysis or plotting, and pandas is what we will use for storing data on our data frame. And for showing any of our plots on the Ipython notebook, we're going to use matplotlib inline, which is called using a magic %sign. For scraping, we stored the URL as a string, and we're going to first call the URL and store it in an object called page using our request library. Once we have that, we're going to parse all the contents using LH, the LXML library that we're going to use, and we're going to parse out all the rows and store them on TR elements using our XPath. But before moving any further, we want to make sure that all our rows are of the same length, as in they all have the same number of columns. To do that, we'll first look at the length of the first 12 rows. So let's run our code. Ooh, this is good news. So this is not a very common phenomenon, by the way, but as you can see here, every single one of our row has 10 columns, which means that we are parsing all our information from the correct TR data points. If we got a number that's not equal to 10, it would mean that we are not collecting data from the correct row. So moving on, now that we know all our T rows are correct, we are going to first create TR elements using XPath. We have an empty column which will store each of the column information. So this code will actually help us to do that. We are going to take each row. So this code is just for the header. So we are going to take each row. We're going to take the first element. We'll take the information of that element, and then we're going to store them on our list called columns. So our column is going to be a list of tuples. The reason we are using tuples is because it's very memory efficient. The problem is that you can only iterate through a tuple only once. So in order to do that, we're going to keep the name, which is the head of each of our column, for example, name, type, total, HP, and right next to it would be an empty list. This empty list would actually store all the column information like 318, 405, 635, etc. So let's run our code. There we go. These are all the header information we have. We have the ID number, name, type, total, HP, attack, defense, special attack and defense, and speed. That's a lot of information. Looks like we'll have some fun analyzing them. Next off, we're gonna fill out this empty list. So as usual, we first iterate through each of the rows. So row 0 is gonna be our header. So we're gonna take everything from row 1 till the end of the row. I mean the last row. So we first take T. We are gonna check if each of the rows are of size 10, because as we said, if it's not equal to 10, that means we are not on the correct one. So we're just gonna break out of it. And then we're gonna do the exact same thing we did before using text content, only we are collecting the data instead of just the header. And anything that's a number, so as you can see here, any arithmetic value is an integer. We don't have any decimal point. So for memory efficiency, we're going to use integers. So convert anything we have into an integer, or we're going to keep it as our default value, which is a string. So let's iterate through our data. Well, we are done. Now let's look at how many data points we have for each column. So look like every single one of our column has 800 data points, so 800 rows in total. Next off, we're going to store it on our pandas data frame. So we have a dictionary which will store title, column. So our title is going to be the header, and column is going to be the list of data, which is basically what we just made so far from col. We import pandas as PD, and then we create the data frame from this dictionary. That was fast. Perfect. Now let's look at the first 5 values. There you go. As you can see here, we have a lot of pretty information. The ID number, attack, defense, HP, name. One problem is that, well, actually 2 problems. First column, the names. You can see that Venusaur, Mega Venusaur, the name is pretty bad. And for type, the types are kind of congested together, and we might want to separate them out into separate strings if we want to analyze different types. So let's try cleaning the data. First off, we make a function called stir bracket, which will basically add parentheses around Pokemon of special types. For example, Venusaur, we want to add a parentheses around Mega Venusaur or any other Pokemon that might be there. And stir break would be to break up our strings, which would into different lists, which will basically be for our type column. So let's just go through the code a bit. So for stir bracket, we're going to iterate. Our input is going to be the term, as in the string, or like Venusaur, Mega Venusaur. We put that in. We iterate through every single character on that string, and then we go through the first set of strings, and we're basically splitting this based on whether it's an uppercase. So as you can see here, the list like character is uppercase. So if a character is an uppercase, we're gonna break that up at that point and add a space between it. So that's what this code is doing. So after we add spaces to it, we are going to rejoin it back to a string. And if our string is more than 1, as in we have a value in there, we are going to insert the first parentheses after our first term or our first word, and the second parentheses after our last term, and then we join them together. And the string break basically does the same thing, only without the parentheses part. We basically split it up and then join it back together. And let's first run this. And now we have a word, I love Pokemon, and we have stir bracket and stir break. So let's test our function. Perfect. So as you can see, I love Pokemon. So after the first word, we have a parenthesis around love Pokemon, and for the other one, it's like I love Pokemon. It just broke it up into three strings based on where the uppercase was. Perfect. Now let's just use our apply for pandas data frames to apply the stir bracket for the name column and stir break for the type column. There you go. Now we have a really pretty data frame. Now that we have this, let's store it on a JSON script. So df.toJSON. I really love pandas because it allows you to import or export to a large number of databases such as CSV files, Excel, JSON, H5, just name it. Just go on the website and look at it right now. So let's just store it. Okay, we backed up our data. Let's try to make sure we stored it correctly. So we're going to open our JSON file, which is using read JSON with our Pokemon data.json. By the way, if you're curious, here's the Pokemon data.json. So what you'll basically see is a gigantic dictionary of Pokemon information. Now we're going to try reading this. Voila, it looks pretty much the same. The index is a little messed up here, but I assure you all the data points are there. Well, that's enough for this video. Next video, we're going to talk about some statistical analysis. So till then, have fun.